Good day, everyone, and a very warm welcome to today's webinar, where innovation meets impact in the South African mining sector. My name is Shannon de Rehove. We're diving into the cutting-edge strategies and technologies that are not just improving mine performance, but redefining what's possible. From precision blasting and predictive maintenance to advances in fuel, lubricants, and digital tools, this session is packed with insights. The webinar is produced in partnership with Investing in African Mining Indaba and is proudly sponsored by Aberdare Cables, BME, DRDGOLD, Engen, Mintek, and TLT Turbo Africa. A big thank you to our sponsors for helping make today's conversation possible. Before we get started, please note that we've activated the Q&A for your questions. Please direct any questions to the Q&A box located at the bottom of your screen. The panelists will answer as many of your questions as possible throughout the discussion. Additionally, the chat feature is enabled for your comments and insights. Look for it right next to the Q&A box. Remember, though, questions should go into the Q&A to ensure they're properly addressed in that section. Please be informed that this webinar is being recorded and the recording will be made available to you afterwards. Also, we're broadcasting live on YouTube and the link will be shared in the chat once it becomes accessible. Today's webinar will be facilitated by Laura Nicholson, the Product Director at Hyve Group's Investing in African Mining Indaba. She's a seasoned mining content creation professional with 20 years of experience in the mining and industrial sectors. Laura will facilitate the discussion with our panel, which consists of Dr Elmark Muller, Executive Manager for Hydrometallurgy at Mintek, Niël Pretorius, CEO of DRDGOLD, Julie Courtnage, Director at Mandela Mining Precinct, Nishen Hariparsad, GM for Technology and Marketing at BME, and Simon Prevett, National Sales Manager for Mining and Industrial at Engen Petroleum. I'll hand over now to our facilitator to take the proceedings forward. Over to you, Laura.
Thanks so much, Shannon, and thanks to Mining Weekly for this wonderful opportunity to moderate this discussion, and great to have such fantastic speakers that are going to contribute to an incredibly interesting conversation. Now, I think we need to paint the scene to start. We need to have context around the importance of technology in mining. We're a slow adopter, I think, traditionally, and we need to change that. And so let's start this discussion by understanding where we are right now with regards to technology in the industry. I think, Julie, I'd like to start with you. You are from the research aspects of the mining world. Why is technology so important for our mining industry?
Thanks very much, Laura. I think we must demystify the word technology. Human beings have been using technology since the dawn of time. Where it was a rock, now it is obviously far more sophisticated. But the driver for technology in mining is many-fold. Obviously, costs is one big driver. All the environmental issues that are coming up is another really big driver. We need to make sure that we are cleaner, safer, and more cost efficient. So I'm going to encapsulate it in those three. Those are the real drivers of technology. Basically, to do more with less, better. Thanks.
A fantastic start there, Julie. Thank you. Alma, you also wear a research hat. So what's your perspective on starting this conversation around the relevance of technology in the mining sector today?
Yes, good afternoon, everybody, and thank you for the opportunity to be on this panel. From a Mintek point of view, similarly, water, electricity, recycling, waste, reclamation, and then fourth industrial revolution. We're active in all of those areas as Mintek, but I think all over South Africa, people are aware of what the issues are. Some of those, of course, are historic and come from infrastructure, but they do affect what we do, and they do affect our way of looking at the future. So those are the important drivers for Mintek specifically, because I'm going to give a bit of a Mintek spin on everything to advertise Mintek. But I think that is South African-wide the drivers for what we're doing.
Thanks so much, Alma. Mintek is doing a lot in the field of technology research. So we're going to definitely dive into some of those areas as we take the discussion forward. Niël, DRDGOLD has been in tailings a very long time. You are a historic company with a great legacy. How does the importance of technology fit into your business?
Laura, there's definitely an operational angle. I think operational efficiency, we rely heavily on technology, and every year there's something else, there's something new. So I'm going to be talking about just operational efficiency, about how we manage our solar farm or our solar plant and integrating it both with the national grid and also in terms of the different points where we use it. From a risk management perspective, very important. From a data capturing some of the predictive analyses that we're starting to see coming through in terms of available technologies. And then also as a listed entity, both here and the United States, governance and assurance that the levels of transparency and the importance of having primary data captured in a way that is, we really only do it once. So you need to make sure that it's done accurately and properly right from the outset. It really plays a big role in that regard as well. So I think it's going to be around governance, around risk management and operational efficiency that I'll probably want to talk about.
Very, very important to the discussion, Niël. So I look forward to exploring those with more detail. Nishen, BME, blasting. You don't think about blasting as being technology driven, but I'm sure that it is. Why is technology so important in your business and in your world?
Hi, everyone, and thanks, Laura. Where do I start with this? I'd like to say, welcome to the age of super efficiency in mining. You see, historically speaking, the biggest innovations in our industry were multidimensional. They allowed for increased outputs, sure, but they also made operations safer and more sustainable. And technology and the smart adoption of technological innovation serves both present and the future, not one or the other. And we as service providers, as BME is a service provider in the mining industry, need to explore new frontiers of efficient, sustainable growth solutions that solve real problems in the current market, which we see can effectively be done through technology, innovation, and integrating mines and service providers across the value chain, whether it be through digitalization, artificial intelligence, autonomous solutions. Either way, adopting technology for us illuminates a path towards improved safety and also super efficiency in mining.
Thanks, Nishen. And two important points that I really enjoyed from what you said. Technology is in the present, not just in the future. I think we have to remember that it's happening now. And that's going to drive our industry, is how we do it now. And also not just the technologies that we have, but how we adopt them as well. So I think you really honed in on two very important points around this discussion. So thank you. Simon, last but by no means least, don't you share your views as an overarching context around the importance of technology from your perspective?
Thanks, Laura. I think my fellow panelists have kind of hit the nail on the head in terms of greater efficiencies and cost reductions that the industry is demanding. But from a petroleum industry perspective, there's definitely concerns around environment and emissions, which is really driving us to innovate our products and supporting services.
Yes, let's not forget the importance of sustainability when linked to the role of technology. But thanks, everyone. I think there's by no means any doubt as to the importance of technology in our sector. And I think it's going to be really exciting to allow each of you the opportunity to talk about some of the innovations that you're currently working on or that you have to offer this audience and share with us. And again, I love starting from a research perspective because in essence, that's where technology really starts from. So Julie, I'm going to come right back to you. And if you could start by telling our audience how Mandela Mining Precinct is supporting the development and the deployment of mining technologies that directly improve productivity and cost efficiency.
Thanks very much, Laura. I'd like to start by saying that before we even think cost and productivity and efficiencies, we have to think safety. And that is one of the drivers behind our technological research program. So the MMP is a public-private partnership for research, development and innovation in mining. And we have a pool of collaborators that actually do the research. And pretty much there is such a long list of what we could talk about in terms of what we're doing, but I just want to give a fairly high-level overview. You know, we have some productivity enhancing technologies that we've worked on. For example, historically, there was the non-explosive rock breaking program that looked at, you know, much safer, smaller blasts, but still delivering the same productivity. So that was one of the things that we looked at. A lot of what the Mechanized Mining Systems program is looking at right now is advancing the remote operated and autonomous mining systems or mining equipment, especially ultra-low profile, for the conditions in South Africa, which, as you know, are deeper than anywhere else in the world. And I'd like to stress here, though, that obviously there is a lot of talk around, will this impact jobs? And I think the important thing to mention is that technology cannot run without people. And in the work that the MMP does, we marry the human aspect with the technology aspect, and I'll talk a little bit more about that later. In some of our other technological developments, we are looking at the digital side of things. So, for example, in terms of efficiencies, one of the tools that was developed under our real-time information management systems is a digital tool to help you make a decision about which investments are best from a digital perspective for your particular conditions. So it's using digital to make digital decisions. So that's one of the tools that's available. And then looking a lot, and it talks, I think, to what I think Dr. Muller, you said, we are also looking at the interoperability of systems. As you know, mining gets equipment from everywhere. And one of the big challenges moving into the fourth or fifth or sixth industrial revolution, however you're naming it, is how does one system talk to another? Because digital is becoming the way of doing things. And we're working on some of those interoperability and what we call producer agnostic technologies so that we can link these things for better efficiencies. We also are looking quite a lot at, as I said, the skills development for technology adoption and about bringing people along with that technology evolution. And towards the end, I'll talk about the sort of gaps and why technology is not adopted. And then also from our advanced ore body knowledge, the strapline for that is glass rock. And what that program is trying to do is for efficiencies in drilling, in blasting, and for safety, of course, and for reduced costs, is can we see into the rock to actually see the faults, the loose rock, the hard rock? Can we create 3D pictures that will then guide, for example, the drilling pattern and make it more specific? So that's just highlighting a few of the items. I don't want to take up too much time, just to give people an overview of the types of technologies that the MMP is currently facilitating or has been supporting the creation. Thanks.
Julie, I just love the idea of a digital technology that helps companies figure out which digital technologies they need. I think my personal perception is that the mining industry can still be quite overwhelmed by the world of technology and where to start. And that sounds like a fantastic tool that really might be an assistance in getting some companies off the ground or giving them direction in terms of where they're going. Elma, from your research perspective, which is more around the minerals processing side, can you share with me some of the technologies that Mintek is working on, especially perhaps with regards to water stewardship and energy transition?
Yes, maybe I should just start to explain a little bit about Mintek. I think the local people know us fairly well, but since this is an international audience, maybe just get a little bit of a background. So Mintek's been around for 91 years. So we have quite a long history. And we as hydrometallurgy, we sit in the what Mintek calls extractive metallurgy cluster. So this cluster consists of hydrometallurgy, pyrometallurgy, and biometallurgy. But Mintek is quite diverse. We have specifically minerals processing division. we have mineralogy, advanced analytical, etc. So we really have everything on one campus. But what I want to highlight today is more on extractive metallurgy. So when it comes to water, just briefly from the biometallurgy division, we have developed technology for sulfate reduction, which is a passive biosystem. And we're actually running a big pilot at the moment at Emathleni, together with Tia and Tungela, etc., where we're cleaning mine impacted water. They don't like to call it acid mine drainage anymore. The word so it's now called mine impacted water. So, and that's from the biometallurgy department. From my department, hydrometallurgy, we also have a chemical process to do similar work where we also reduce sulfate or remove sulfate. We can go down to about 10 ppm of sulfate. It really is a case of horses for courses. Depending on what the feed material is like, we will come up with a solution and give you a solution to your issue. When it comes to electricity, specifically in the pyro department, they're doing a lot of development on hydrogen reduction to get them away from using a lot of carbon when it comes to an iron furnace. They're really doing a lot of development work on that. Also doing different preheating systems, etc. All of that to remove or to reduce the use of electricity and remove some of that from the issues. Then again, back to the bio department, they also do a lot of heap leaching development, and we're looking at different ways of heating the irrigation solutions, for example, to improve heap leaching. So it's a really diverse. And then back to hydrometallurgy, as I said, we've been around for 9 decades plus now. So we even have older technologies that's been or that were developed in the previous century even. We have a Goli, for example, that was developed in the late 90s, early 2000s, which is a system whereby you can leach gold without using cyanide or using mercury or any of these toxic chemicals that can be applied by small-scale miners in South Africa. There are even we're constantly also improving our carbon in leach, although gold mining in South Africa is declining, unfortunately, although we've all read about a new mine being opened in the last couple of weeks, but the gold mining is declining. But we're constantly looking at improving even our older technologies that's been on the market for a long time to make it better, to make it more efficient, to look at leaching at lower levels. As you all know, that everywhere in the world that the grades are decreasing because the easy stuff's been mined. And even BME can tell you, how they need to change their explosive technologies. So it's all about improving, constantly improving. So we don't just do new technology development, which is of course something we do, but we also look at how can we improve what we currently have and make it better and make it more efficient. We also have an advanced electronic division, for example, that have developed various online measuring systems that they can implement globally. They're currently in 45 countries around the world, where they have instruments in mines, and the guys can sit here locally in Randburg and they can actually tell people what's wrong on their plant in Brazil or even in Kazakhstan, wherever. So we're really diverse. I must say that is one thing about Mintek, is that we look at where's an issue and how can we try and help and resolve that issue. We've developed various technologies for the manganese mines here in South Africa, looking at making manganese sulfate, for example, battery quality manganese sulfate that will go into electrical vehicles. Although it's a couple of steps removed from an electrical vehicle, in the end it will end up in an electrical vehicle. So it's
Elmark,
really...
if I can just stop you there, because I think you're going to give away all your exciting info in one go. So let's save some of it for the whole conversation. But also a very, very old institute, and it's good to see that you're taking care of older technologies that are very much within the industry, but also thinking new age and what's needed in the new age part of mining. And we definitely want to explore how that technology research actually gets implemented into the industry. We'll touch on that a little bit further, but just clearly incredible amounts of work that you're doing in this regard. So thank you for sharing that amazing work. I think now it really makes sense to move to the implementer, someone that's taking that technology and applying it to their own operation. And Niël, DRDGOLD is definitely doing this. So can you tell us how you're using technology to specifically improve efficiency and environmental outcomes, but at the same time, still extracting the greatest amount of value that you can from your tailings?
Yeah, no, certainly. We really had to take a long and a hard look at how technology can assist when the basic construct of our business changed. So when we started moving away from plants with relatively modest throughput profiles of around about 250 to 300,000 tons per month to the mega volume plant at Ergo, where we were processing between 2 and 2.2 million tons per month, it became apparent that with the low grades and the high volume throughput, the conventional way of reactively managing the plant was simply just no longer going to cut it, because it just got away from you. You had to proactively mine this. We're taking out roughly 200 parts per billion. So it's a process that's going to be extremely finely tuned. You're talking about mega volume on the one hand, and you're talking about nano extraction on the other. And so we used existing technology, but we just applied it, I think, in a new and in a smart way. So the normal SCADA system, and coupling that with your PLC technology of setting up the plants in such a way that we refer to it as the non-negotiables were managed to within very specific ranges. So your densities, your cyanide consumption or concentration, the temperature in various aspects or various parts of the business, the pressures in specific parts of the plant, and so forth and so forth. And whereas in the past, for example, pH was measured by way of just spot checks from time to time. And then you would have the situation where the person who checked the pH would say it's either too high and too low, and then he would apply dosage or withhold dosage, and then just measure it when it was right on the number. So you got a flat line in your reporting because it was only taken once every periodically. But in the meantime, your pH is in flutter because he's just sort of picking the right moment to write down what the measurement was saying. Now you're doing it 24/7. And that's how we finally managed to bring about a measure of stability within the plant. And interestingly, what it did was, firstly, it made the plant more predictable. Secondly, as we were starting to understand the performance of the plant a little bit better, those ranges became narrower and narrower. And even more importantly, the kind of conversation that we were picking up, operational conversation, started becoming far more analytical. Why is it behaving like this? And can we maybe change this? And what is the impact going to be? You could actually see that by way of just studying these different graphs. So that was in terms of operational efficiency. Now our business, which processes about 25 million tons of material per year, we have a network of pipelines that carries material from our various reclamation sites to the plants that we have here in Johannesburg in particular. And these things run at very, very high velocities and very, very high pressures. You've got to keep that thing in motion, or else your pipelines, your pipe columns would choke up. So when they burst, it's not a pretty sight. And typically they only burst sometime after they've sprung a leak. And one of the most fascinating technologies that we've come across recently is leak detection. So there's a program with a number of probes. It's a number of probes linked to a program, obviously. It's been installed. And the service provider is not even in South Africa. They're sitting remotely, I think, in Europe. And they're constantly monitoring our pipelines. And I say these are 0.5 meter in diameter pipelines. We're running over 30, 40, 50 kilometers. So if that pipe bursts, you've got 10 kilometers of slurry coming down that pipeline. It's just a complete mess. It's really not pretty. So what these guys are doing is they're picking up through artificial intelligence, through algorithms that have been programmed and that keep on improving. They monitor the condition of these pipelines, and they actually manage to tell you where a leak is developed to within a few meters of where that actual leak is through technology. And this for us has been a wonderful piece of innovation, especially from an environmental perspective, from a visibility perspective. So notwithstanding the fact that we're a very large company in terms of throughput, we want to be invisible. We don't really want people to know that we're there, because you notice us typically in a negative way when something goes wrong. So these guys help us to make sure that things go wrong, so that things don't go wrong. So from an environmental management perspective, from an operational efficiency perspective, those are some of the technologies I think that I can, that I think are probably most appropriate for this conversation. In terms of some of the other things that we do, the solar farm, construction and so forth, we can elaborate on those a little bit later. But directly to your question, I think those are the most interesting ones.
Thanks, Niël. And that makes the reality of what we do just real in terms of some of the challenges that we have to face and how technology can provide an answer. And I think there's a lot of the world that don't feel like those two worlds can intersect, and you've just demonstrated just how well they actually can. So extremely valuable for sharing what you have, Niël. Thank you so much. Nishen, blasting. I happen to believe that within the blasting world, you probably are one of the strongest innovators in the general service provider sector. So tell me how BME in particular is leveraging digital blasting technologies and data analytics to drive improvements in mining efficiency.
Thanks, Laura. For us, we solve for the market and for the market in which we operate. And we acknowledge that as miners look ahead, we all know that efficiency in mining applications is the main force behind a winning strategy. We also know that the parameters of an efficient operation are also shifting with the arrival of new technologies, and that doing things the same way with fewer mistakes is not enough. At BME, we've developed our technologies with this in mind, that is responding directly to what the miners of today are looking for. You see, digital blasting technologies and the effective use of data analytics across the mining value chain highlights how technologies can play a vital role in not just improving productivity and efficiency, but also help steer miners on a sturdy path through turbulent markets. For example, our Access Electronic Initiation System and our Blast Alliance suite of softwares are integrated what we call partner systems for miners' operations that have been purposefully designed or developed to unlock measurable value immediately. This is value reaped through better fragmentation, reduced downtime, and also downstream productivity and efficiency benefits in areas like achieving faster excavation and more efficient processing with every successful blast event. For BME, digital blasting technologies and the effective data analytics are strong examples of productivity and efficiency tools because they unlock visible results, such as fewer blasting days, reduced vibrational disturbances, and optimized maintenance programs, and are further exposing and reducing inefficiencies across the mining value chain. And I know it might be hard to associate blasting with generating value because we break rock, but I'll put it to you this way. Our emulsion systems, we don't sell emulsion, we sell energy. Our detonators, we don't sell detonators or initiating systems, we sell predictability. Our software solutions, we sell empowerment, allowing our customers and the environment in which we operate to do more with what they have. I hope that answers the question.
It does, Nishen, thank you. And I'm correct in saying that blasting companies such as BME are really innovative when it comes to technology in the mining industry. So thank you for sharing some of the things that you are actually working on. Now, Simon, when we think fuel and lubricant technology, do we get excited? We should, because it leads to longer lasting mining equipment performance, which is very, very important in the sector. So how is Engen leveraging advancements in fuel and lubricant technology?
Hi, Laura. Yes, we do get very excited. So, yeah, Engen has a number of products and services that are really aimed at driving efficiencies for our customers. And I think one of them is our dynamic diesel, which uses a bespoke additive technology, which we call ProDrive, which is unique and patented to Engen. We're very proud of it. And it sort of works in two ways. It improves the atomization in your combustion chamber, which improves the efficiency of the combustion. And it also keeps your injectors cleaner for longer, so you don't get carbon buildup, so you maintain your spray pattern. And well, that all sounds very complicated, but in real life, and this comes from our customers, we're seeing better responsiveness from equipment of about 4%. We see 2% power improvements, and the important one, fuel efficiency of up to 3%. Which I think, from looking at the environmental concerns and the drive for better efficiencies are fairly significant numbers. On the lubricant side, we have a comprehensive range of synthetic lubricants, really future-ready products, as well as energy efficient lubricants. So these all aim at reducing emissions, reducing power consumption. And of course, the added benefit of synthetic products is extended component life, which ultimately leads to higher efficiency, higher equipment availability as well, and less breakdowns.
So pretty important when it comes to it, and fantastic results that come from that technology use. Simon, thank you so much for sharing. Now, I do want to come back to Niël, because the operational implementation of technology is just so important. And Niël, you're implementing technologies. I'm just wondering, how do you do that without disrupting what you're currently doing on site? Because that disruption cannot afford to take place in the running of an operation. How do you do that? And can you share perhaps some of the lessons that you've learned when going through this process of adopting new technologies into your operations?
Look, whenever you want to adopt a new system into an already established set of protocols, you have to be mindful that, especially in an operation like this, which is fairly sensitive to a variety of things, like volume, throughput, and efficiency, and so forth, people don't really want you to experiment on something that's been working and working well. So you really have to do it incrementally, and it's important that you do get buy-in. So you've got to get your technical experts to really. They need to be convinced of the value of this. And I mean, we've intentionally delayed the implementation of certain technologies in order to make sure that we get through that process. And there's also a line that I think we don't really want to cross. So you could take technology up to a particular point, but we're not particularly keen on autonomous systems. So obviously there are certain fail-safes, especially with your PLCs. There are sometimes direct interventions around safety and health, etc., etc. But you really want the operator to ultimately be the dominant partner in this technology human sort of partnership or relationship. So yes, there have been instances where maybe we had to sort of nudge things along a little bit, especially where around the management of information and data and so forth. In the past, it may have been sort of treated as currency, and now it becomes more freely available, and it's hard to sort of find your balance in this new environment. But once it starts working, and I think once people see the merits and the benefits of implement technology, they eventually settle in and they embrace it, and they start using it as an important tool. Obviously, whenever you're doing something completely new, you want to, especially nowadays where technologies are more freely available, you want to have the right sort of technology available right from the outset. And I think our solar plant is a very good example of that. I think we were amongst the first solar plants, if not the first, that operates on 5 different levels. So there's a direct consumption where without any meter in between, we feed external meter in between, we feed power into our infrastructure, into our systems. Secondly, we store power in a 180 megawatt battery storage system. We feed power into the grid. We draw power from the grid, and we also draw power from the batteries. And the way that this, and sometimes you just look at a system and you think, how on earth did they figure this out? Because this thing balances itself. Depending on how much solar power is being generated, the amount of power that's being drawn from the grid is automatically reduced. If the sun stops shining and you've got to draw more power from the grid, it looks at what you've got left in your battery system, it looks at what you can draw from the grid, and it automatically balances that. So, I mean, this is a really smart technology, and as I say, I think this is just, it's fortunate that we were able to build this facility at a time when these sort of technologies are available. And then also when it comes to construction, there's a conventional way of constructing things and building things, but again, depending on what it is that you're building, the controls, the quality controls in particular, have become very, very important, both from a compliance perspective, but also from an assurance perspective. And it's we're building a tailings facility now on the other side of between Carltonville and Fourville. This facility is 800 hectares in size. It's 14 kilometers circumference. It's got a starter wall that's 25 meters high, 100 meters wide. And it's being built by basically placing one layer of dirt on top of another in layers of 30 centimeters, about a foot. And there's a device that, and the density and the moisture content of this is going to be exactly right, both in terms of the starter wall, but also in terms of the surface of this facility that's going to be lined. So I'll talk about a little bit about that if there's time later on. But just in terms of the starter wall, there's a device that actually drives over newly compacted material on top of this facility, on top of the starter wall rather. And it automatically measures and records the density, the compaction, and the moisture content of the last layer that's just been placed there. So you're not going to find yourself in a situation where 10 years down the line, you spring a leak and you find out, but hang on a second, the material was wrong, the density was wrong, the compaction was wrong. It's picked up in the minutes after it was done. And they won't put the next layer on until that layer is fully compliant. You look at this, I'm not an engineer, but you look at this and you think to yourself, these guys have a really interesting job because they get to work with some pretty interesting technologies. And this is from a risk management perspective, from a quality assurance perspective. If you're going to be spending 7 billion rand to build something, it's nice to know that it's being checked and verified to the extent and to the level that they do. And that's all technology.
Especially in the world of tailings, Niël, which we know has had some fairly unpleasant disruptions in the last couple of years. So that sounds extremely exciting.
You don't want a pipe to burst, but you don't. The one thing that you really, really, really don't want to fail is a tailings dam. No, you're absolutely right.
And if we've got technology that can solve that problem, I think we're onto an absolute winner. And I think the takeaway of everything you've shared takes me full circle almost back to where Julie started, which is really identifying technologies that are suitable and applicable to your specific needs and your specific operation. And Niël, that's exactly what you've done in your world. So Julie, let me come back to you at this point, because I understand, and what, we've talked a lot about new technology, but as Alma pointed out in the beginning, there's older mines, there's older operations, and they have their own technology needs, or it's different. And I understand that the Mandela Mining Precinct has a longevity of current mines research program that helps to extend the life of deep level operations with technology. Tell me a bit more, Julie, about that program, because it is kind of coming full circle to where we started and where we are right now in this conversation.
Perfect. Thanks, Laura. So yes, LOCM, as we fondly call it, was really designed originally. So the Mandela Mining Precinct has been in operation for 9 years. Although formally we were launched in 2018, but since the beginning, there's been that recognition of South Africa's got a lot of mining. So how do we do more with what we already have? And LOCM was designed around optimizing resource extraction, improving productivity, job retention, particularly for our deep gold and platinum mines, so the narrow reef hard rock. And the imperatives behind that is improving, maintaining and improving health and safety, increasing extraction efficiencies, and reducing the operational costs. So it very much talks to this webinar. And one of the key aims of the Longevity of Current Mines program is to identify and address the gaps in the mining cycle that hamper the 1 quality blast per day kind of target for most mines. And so there's been a lot of technology developments around within the LOCM, and I'm just going to highlight a few. The Isidingo drill was a challenge that was run a few years ago. I'm sure we always talk about the Isidingo drill because it was such an amazing breakthrough.
It was,
and
Julie.
In summary, in the space of just a few months from the challenge going out, two companies came up with a drill that in the people who won the challenge, the drill is 50% lighter than standard drills. So immediately women can use it with a lot more ease. I can't remember the percentages, but it used less water and it uses less energy. So that is available in the marketplace right now, and that arose out of the MMP LOCM program. Another a very important one, because as you go deeper, of course, it gets hotter. And one of the technologies that you can get all this information on our website is an in-stope environment cooling system. And there's reports there on that specific research thrust, which is obviously very important for the deeper gold and platinum. Linked to autonomous, the autonomous program in mechanized mining systems, one of the technologies that was developed was a remote charging unit. Obviously, the deeper we go, and with some of our older mines, there's obviously, increased risk of falls of ground or loose face. And this remote charging unit was developed in collaboration with the University of Pretoria and it is obviously cost efficient, aims to remove people from the face in these more dangerous conditions. But then moving to the human side of it and the business side of it, which is equally important, is that LOCM also looked at shift cycle optimization framework. Because obviously the deeper you go, the longer it takes to get to the face. And you've got to take into account the technological and the human and the cost aspects of that. So LOCM doesn't only look at technology, it looks at the impact of technology on the business and the impact on people and the impact of people on the business. Then I think another one that I'd like to highlight, just looking at my notes, is the remote scraper cleaning with proximity detection. Again, the deeper we go, the more difficult it is to manage these, I'm going to call them remote because they're so far underground operations. And this one particularly obviously looks at safety, but if you can get remote placing as well as remote cleaning, you've already removed people from that potentially dangerous situation. And it can be optimized in terms of cost, in terms of when you use it, how you use it, under what conditions you use it. So those are some of the highlights. But I think what I'd like to also mention is that increasingly at the MMP, although we currently have these 5 programs, we're starting to see these programs integrate. So, for example, in our advanced ore body knowledge, and I know you asked about LOCM, but in advanced ore body knowledge, if that program is looking at a particular drill bit for improved drilling, we're now going, well, what sensors need to go on that? So that, we're actually looking at sensor-guided drilling to make it more precise and therefore more accurate and therefore more productive and therefore more cost efficient, as well as safer. Because if we can detect faults, if we can detect loose rock, if we can detect the proper placement of that particular blast hole, it all comes down to cost efficiency, productivity, but most importantly, safety. So I've got a list of at least half a dozen other technologies, but I don't want to take up more time. So that is a high-level summary. But as I said, all of this is available through our website, which, by the way, we are relaunching soon. Watch this space.
Thanks, Julie. I hope it looks super techy and savvy when you relaunch, because you are doing some pretty amazing technological developments there. There's some wonderful questions coming through from the audience, and I want to dive into some of them so that we do touch on them. And Elmar, there is a question here for yourself, and the question is from Kiela Bocho, and they are asking, what technology is Mintek currently exploring for improving carbon and leach processes? And I think when you talk about that, the thing that I wanted to know from yourself, Alma, is when you do all of this research, how do you make it scalable? How do you bring it into the industry and make it that it applies to large scale applications? Because that's what mining is. So a bit of a two-part question there. First around CIL, and then the second around how you scale technologies to just actually be implemented from a research point of view to a market point of view.
Look, the improvements that we made on CIL, depending on the application, because we don't burn the carbon in the end, we recover whatever is absorbed on the carbon. So we have improved it in the sense that we can separate out the gold for you. And if you, for example, have a sample that contains base metals, we can give you a separate base metal stream. We recover those, or during our recovery from the carbon, we can already do some separation to give you different products. So we've done that improvement. Then when it comes to taking research into implementation, Mintek, we have actually pilot facilities on site. So we can run in hydromet division, for example, we go up to a couple of tons of material that we can process here. In the pyro department, I have up to 2 megawatt furnaces. So we can do bigger scale here. So how our approach normally is, we do research and then we look for industry partners that will then work with us during the piloting so that they can actually see the improvement, they can see the benefit, and then that would then go towards the client so that they can do it on site. One of the pilots that we did last year, for example, was recovering of rare earth material, and we processed in our pilot by 27 tons of material over about a 2-month period. So we are fortunate that we do have the infrastructure to do that here in Randburg. And people don't complain about the smells or the noise or the whatever. So we are pretty effective in how we manage it. But we can do that, yeah. But in our view, really getting it into the industry is that the sooner you get an industry partner to work with you, and that will then really make it much easier to implement, because as some of the previous speakers said as well, this industry is extremely conservative and they do not take well to change. So the sooner we get the commercial clients involved and get their buy-in, that just makes the adoption so much easier.
Thanks, Alma. And I'm going to do a little mining Indaba punt there, because our theme for next year is around partnerships. And in the case of technology, you can have a great technology, but if you don't have a partner that's willing to work with you in order to adopt it or trial it,
yes,
it becomes extremely difficult to get off the ground, which is why the concept of partnerships in this industry is so incredibly important, especially when it comes to new technology. So really, really valid point that you raised there as part of this conversation. Thank you, Alma. Nishen, I've got one or two questions from the audience for you. So I'm just going to pick the one at the top of the line here, which is from a guy called Michael. And he's saying, we're yet to find a solution to the issue of emulsion runaway, where the ground would be heavily fractured in the surface blasting operations. So is there emulsion that is so enhanced such that it doesn't escape through the ground through cracks or discontinuities?
Yeah, no, that's a great question. And as Julie mentioned earlier, it's great to have technologies, but without effective implementation and using our resources, our people, to implement these technologies effectively, it'll be a bit challenging. But yeah, to answer that question, yes, BME specifically has a specific product. We call it our Innovex 300D product. It is a product that is a patented homogeneous modification method that allows us to make the emulsion a lot more viscous, to allow for various rheologies and various different geologies as well. And that one of them is to avoid runaways through through cracks or voids in our drill holes, as well as through dynamic water conditions. I mean, we've mentioned it previously by many of the speakers that mining is becoming a whole lot more difficult, and therefore for service providers like us, it's very necessary for us to continually innovate such that we can develop technologies that can talk to these solutions. And our Innovex 300D formulation is specifically designed to tailor for runaways, to tailor for emulsion loss through cracks and voids and rifts and that sort of thing.
Fantastic. Let's hope you've just solved a client's problem there, Nishen, with the product that BME has on offer. I love that. Simon, we have a question from the audience for yourself. Slightly interesting question, but I'm going to throw it at you. It's from Tennis, and he's asking if there are new technologies used to move away from coal-based fuels and the historic consequences that come from using coal-based fuels.
Thanks for the question. Great question. I'm assuming he means hydrocarbon-based fuels. So,
I assume so as well.
We'll stick with that. So I don't know how long he's got, but this could take all day. No, I think really currently the focus is on the existing technology, so the internal combustion engine, and it really focuses on improving the efficiency of the current technology, and then reducing the emissions that it produces. So particulate filters, for example, catalytic reduction units that help reduce the harmful component of the exhaust gases, and then the slow sort of migration to alternate fuels. There's already talk about potential LPG or biofuel introduction, where you basically use biomass, so a crop, to generate fuel, which obviously you burn. And that allows you to sequester carbon from the atmosphere, and fundamentally it becomes carbon neutral. So I think those are all technologies that are in the pipeline, and then driving efficiencies, looking at frictional losses and then drivetrains. So that's where your synthetic or your more advanced lubricants come in. So there's a number of technologies, but I think hydrocarbon or fossil-based fuels will be around for some time to come. It's just how we manage the energy mix going forward.
Also very important, managing the old with the new and how you phase something out and phase something in. Thank you, Simon, for that. Niël, we have a question from our audience, and they're just really keen to understand your solar power system in a little bit more detail. They're asking for a site visit, but for now, I think it would just be a good opportunity to share more about how the system works.
Yeah, no, certainly. Look, we have posted a few videos on YouTube, so they're accessible, give you a good idea. But it's a 60 megawatt solar farm. So we have a requirement for about 15 at any particular point in time. The balance goes either towards our battery storage or into the grid. And effectively what this allows us to do, if it's running at design capacity, is have renewable power for about 12 hours every day. And then of course, when the sun's down and the powers of the batteries have been drawn down, we make use of that period after dark when electricity costs a little bit less, when it's not at the peak rates, to recharge the batteries. And then early in the morning, when we go back to peak rates and before the sun's out, we then draw down the batteries once again. So it's a combination of combining battery storage with grid capacity with the solar capacity. In terms of the technologies that we use, those are bespoke technologies that were designed to keep this whole system in balance, and that's more or less in line with what I described earlier. When the sun's out, it draws less power from either the batteries or from the grid. When the sun's not out, it sort of balances itself seamlessly. So it doesn't make any loud, sudden noises. That's the sort of thing that you want to avoid when you combine these different sources of power: batteries, solar farm, and the grid.
Thank you so much, Niël. It's always just fantastic to hear solar being applied to a 24/7 operation. It's just fantastic technology to be seeing implemented. I think at this point in the conversation, we've had a lot of positivity. We've spoken a lot about technologies and how the industry needs to adopt them. But the reality is that there's a large portion of the industry that is quite slow to adopt them. And Julie, I want to bring this back to you. What do you think are the biggest obstacles when it comes to adopting technologies in the mining space? What's holding us back? Because there's so much out there, as we know.
Right. So, Laura, I think you've just specified one of the issues. There is so much out there. And people mustn't forget that mining is not like opening a grocery shop. It takes an immense amount of planning. It costs billions, and the development can be quite slow. So the sheer nature of mining is partly what prevents us. It just takes a long time. But then there's a couple of distinct factors. So imagine someone comes up with a brand new super duper haul truck that is just, energy efficient, water efficient, helps keep the driver awake, and is made out of recyclable material, I don't know, or recycled material. If a mine has just invested a few billion in capex in a new fleet, no matter how brilliant that technology is, they simply cannot afford to invest in that. So something that I believe needs to be done is a lot more transparency on linking research and innovation into investment cycles, because that would help make sure that we sort of dovetail, although across the sector, of course, that would be quite difficult. But I think that's the one big barrier, is the genuine long-term capex investment cycles of mining. Then the other, for me, one of the biggest issues, and I saw there was a question posted and I tried to answer, is too often, because we're all either engineers or scientists or something like that, we think technology is the answer. But the reality is we can't look at technology in isolation from the business that is adopting it, the organization that is adopting it, and the people who have to use it, i.e. the people who have to adopt it. And one of the projects we are currently busy with, it's been in progress for a couple of years and it's got a couple of years to go, is we are, as I said earlier, now looking at absolutely tying together a framework that looks at technology readiness levels, which is a whole other conversation anyway, human readiness levels. If you have a technology readiness level of 9, in other words, it's ready to be commercialized, but the people on the ground have not been brought along, or it threatens a job, or there's just plain old fear around that technology, it will not be adopted. So we're running this research program that looks at the matching technology readiness levels to human readiness levels, business readiness levels, and organizational readiness levels. So I think one of the biggest barriers is that we view technology in isolation, rather than as part of a system of systems. So we cannot divorce any technological development from the people, from the realities of mining investment cycles, and also from the fact that what works for a narrow reef hard rock mine 3 kilometers underground might not work as well in a manganese or a coal mine, 500 meters deep. And so very often technology is highly specific to the context in which it's got to be used. And that's one of the risks of what we call off-the-shelf technologies, that they might actually be applied under the wrong conditions and prove to be extremely costly because they don't work, or even worse, injure someone or cause a death. So there's all of those factors that play together.
If I could add, sorry, Laura, if I could add.
By all means, Nishen, go for it.
To Julie, necessity, as the saying goes, is the mother of invention, right? And generally, the seek for new technology comes around when there's a challenge that needs to be solved for. And it's very important that with all the technologies that exist and all the innovations that we have at our disposal, sorting through these innovations and finding the ones that really work always comes back to ensuring the strength of partnership. And it's really important that when we implement technologies, we shouldn't implement them in isolation or, as Julie says, a system within systems, but rather work towards partnerships that are meaningful, measurable, and valuable. Something that we can talk to what we're trying to solve for, not an independent solve for what a specific technology has. And I think that's very important for us in seeing technology and innovation being completely implemented, embedded, and delivering value across the mining value chain, and not just for a service provider, a customer, a mine.
Yeah, Laura, if I may add one very quickly, thanks for that, Nishen, because you prompted my thinking. Another issue that impacts technology adoption is information that's available about it. And because information drives innovation. And too often, people just don't know what's out there, as you're saying, Nishen. And so it's important, and we're trying to play a role in that in our 2030 strategy to make sure that people become aware of what's available. The Mining Equipment Manufacturers of Southern Africa, MEMSA, has what we lovingly refer to as the yellow pages for mining equipment, called the Technology Availability and Readiness Atlas. So it's TARA, the mining TARA database, and that's available to anybody just to go and see what equipment is available. But information flow is absolutely paramount for these innovations and these technologies to be adopted. And we need to see that the same kind of transparency that we have on safety. When I started in the industry 35 years ago, safety was viewed as a competitive advantage. And I know that obviously there will be confidential information around new innovations and new technologies, but we've got to move the industry to a mature perspective of, if this can help a broader group of people without revealing anything confidential, let's share that information.
Let's not deny the complexities that mining is, and what is required to really find the right solution for the right problem. And Julie and Niël, you're just kind of singing on the same hymn sheet about that. It just really stands out as being so important. Elma, I know that Mintek is extensive when it comes to research and development, but if I asked you from your perspective on a larger scale, do you think enough research and development has been done for mining technology in the industry at large?
Oh, that's not such an easy question to answer. As a researcher, I would like to say no. I don't think enough research is being done. But it's also a funding issue in the end. Because, I mean, as Julie said, and Nishen, and some of these, it's normally requires quite a huge capital injection. So people do want to back a horse that they kind of know will win. They don't like to throw money at stuff that might or might not work. So it's not an easy time, and it's linked to commodity cycles, etc. So, but I don't think enough money is spent on the research and development. I think globally, and I've spoken to guys in Australia and in America. Overall, there's a decline. Most of the mining schools are seeing a decline in the number of students that they're getting. So overall, it is an industry that's currently not being seen as sexy and wonderful, etc. But everybody wants a phone. Everybody wants the latest phone, and they don't realize that without the metals and minerals processing research, you're not going to have the new phone, because there won't be material to make the new phone. But I don't think there's enough research going into it. And I think especially the pressures lately on ESG and the way that mining is being done, a lot more research needs to be done, because mining will always be required. As a mining researcher, I'm saying that, but we can do it better. We can do less harm to the environment. unfortunately, you can't say we're going to mine and do zero harm. I still want to see a process where you can do that, but there's a lot more research that needs to be done. And unfortunately, that takes time and money to actually get there. So long answer, but no, I don't think so.
I think we as an industry have a lot of work to do with regards to promoting ourselves, and how we're positioning ourselves as a technology adopting industry. I think that's on all of us to work through. But very valid point. Thank you, Simon. We've talked so much about the impact of technology and how it makes us safer, more energy efficient, transitioning us towards a cleaner future. What is the role that Engen plays in delivering on those goals?
Almost was a victim of the mute button. Thanks, Laura. So yeah, I think we kind of touched on it before, but from a number of perspectives, we really start with the fuel. We offer a low sulfur fuel into the market, less than 10 ppm, and this combined with some of our low SAPs, sulfate and phosphorus lubricants, and diesel emission fluids, so AdBlue. These combined really help reduce the harmful emissions from the exhaust, and also help protect the engine emission control devices. So our fuels and our lubricants are fully future ready, and fully compliant with the future technologies that the OEMs are putting out there in terms of emission controls. And sort of stepping into the future in terms of alternate fuels, we are busy assessing some sustainable biofuels offering with some customers. Lubricants on the lubricants front, they're progressing to really low viscosity products, so really reduced frictional losses, so you get improved powertrain efficiencies, and much longer product life, so you're putting less product back into the environment once it comes out, and you've got to dispose of it. And then we're also now layering on top of that some services. So we use FluidLink as our services brand, and we really look at lubricant consumption, the right product in the right place at the right time, and especially in the industrial and the mining plant spaces, we're seeing reductions or lubricant consumption of up to 60%, which is a really phenomenal number. And to that, and I guess it's not something that you associate with a petroleum company. We've recently started looking into a unique technology that for customers that are using backfill or backfilling, and they're using cementitious mixtures. It's an additive, or I would call it a friction reduction additive, if you will, that can be added to the mixture. So if you're pumping a slurry concentrate or a cement, it reduces the pumping pressures, which really is reduced energy consumption on behalf of the pump. You require less water to do it. You have less blockages in the system. So there's some interesting technologies coming. I think really for us, the advance is looking towards, AI is another thing. We all use ChatGPT. I think that animal is upon us. And we introducing some new technology in that front as well to help with predictive maintenance, which I think is one of the future terminologies.
Brilliant, Simon. Let it not be underestimated, all the incredible technology and work Engen is doing in the world of fuel and lubricants is quite incredible, actually, and quite amazing, and the impact of this is quite substantial. Now, we will remain in this world of big impacts of technology, especially from an environmental point of view. And Shen Tienes, I think he asked your last question, but he's got another one for you, and he's asking about greenhouse gas reduction in mining and operations, and what is the latest technologies around that. Now, I know you're particularly keen to answer that one, so over to you.
Sorry, Laura, was that for me?
It was. It was, Nishen. I wasn't sure if my screen had frozen or if you hadn't heard me. I'm glad you've heard me.
Yeah, no, I think that's a great question. I think for us, it's really important that, we need to embrace new technology. And sometimes new technologies might come around in unconventional forms. For us, if I can give an example, typical emulsion systems use ammonium nitrate. Ammonium nitrate by chemistry produces noxious gases, which are toxic to our environment, provided it's oxygen balanced. That will eliminate that. At BME, we've partnered with a company called Hyve Bio. Hyve Bio produces emulsion systems through a very unconventional means, which is hydrogen peroxide, right? Hydrogen peroxide by chemistry cannot produce nitrates. By its very chemistry and nature, it cannot produce these toxic fumes that leads to leaching in our tailing dams and in mine waters and the environment. So utilizing technologies that are out of the box, so to speak, is definitely a step in a way to get closer to the 2050 net goals and improving or reducing greenhouse gas emissions, in my belief. And also, we spoke about the various technologies that we have and various systems have. The intelligent application of those technologies can be used to tailor the outcomes we require. Therefore, it's very important for us that when we design a blast, for example, it has to be done in conjunction with the mine, with the environment, with the partners of the mine, with the other providers that exist on a mine, such that we can deliver on the outcome. And for example, minimize disturbances through vibration, that sort of thing. So intelligent application of technology, as well as looking outside the box and adopting unconventional means, will help achieve those GHG emission targets.
Fantastic. Thank you. Thank you so much, Nishen. I've got, I think, a last question for Niël, and then I would really like to round the conversation off with some closing statements. We've said a lot of things, and a lot of things have come to mind, I can see, as we've gone through this conversation. So some wrapping up statements, I think, would really close off and contextualize the conversation at the end. But let me give this last question to Niël. Niël, I don't know if there's an answer to this, but maybe there is. Maredi is asking how or if, I suppose, technology can help with soil rehabilitation on tailings dams or mine dumps, so that you can have a healthy earth to allow farming to take place on that land. Is there any technology associated with soil rehabilitation or anything in that sort of part of the tailings world?
Not really, no. I mean, the technology could perhaps assist in making the material that you place into that tailings dam or onto that tailings dam a little less toxic. And then there are technologies, for example, for cyanide extraction, etc., etc. So it's what you do before it ends up on the tailings dam itself. Once it's there, really what you want to do is contain it. Cyanide, for example, gets broken down by exposure to sunlight, but some of the other heavy metals and salts and so forth, those you've got to contain. So technology to contain the impact that it has with regards to the environment, those technologies are increasingly forming part of the codes that apply to the management of tailings dams. And what we've done on our permanent tailings storage facilities, the ones that, because we reclaim tailings or material, we don't backfill it onto the site where it gets reclaimed from, it goes onto another tailings dam. And those are the ones that are going to be around for a long, long time, until technology improves and they can be mined again. But until such time as they do, we clad the outside of the tailings dam. We basically cover it with soil or with mulch, and then we establish vegetation. And then we allow nature basically to take over and to restore that site. And it's amazing to see how once natural vegetation finds its way back onto those dams, how how biodiversity just explodes, and how natural sort of insect life, bird life, etc., how all of that would come back, and they don't know that there's an artificial reality less than 30 centimeters away from where they feed and breed and live, etc., etc. So that's typically the sort of thing that I think where technology comes into play.
Yeah, it makes a lot of sense, Niël. Thank you. It's not the end result that matters, it's what you do before you get there. Thank you. So I think, as I said, it would be a great moment in time now to just wrap up the conversation and contextualize everything we've shared. And from my takeaway, it's not what does technology do for the future of mining is what does technology do for mining and this industry right now. We don't have to think long term. We should be thinking about it right now and implementing it right now. So I'll start in the same order that I started. And Julie, with you, your key takeaway, your lasting message with this audience today regarding our conversation and technology in mining.
Thanks, Laura. Don't forget the people. So when focused on technology, make sure that you design it with the people in mind. And to mirror what Nishen said, we can't do this alone. So the more we collaborate, the more effective partnerships we have, the better the industry will get at both developing technologies as well as adopting them and implementing them. Thanks very much. Really appreciate this opportunity.
Solid message, Julie. Thank you so much. Elmer, over to yourself. Key takeaway message for our audience today.
Yeah, just to mirror what Julie said, you need to involve the communities, get their buy-in. You can have the best technologies, and if you don't have the buy-in of all the stakeholders, I think the view has changed in South Africa, or is changing, but we still have community issues. I think the sooner people get the buy-in, get everybody involved, and that people can see the longer term benefit, not just short term now, but can see the longer term and can see the benefit to everybody, it will make our lives a lot easier.
Let's not be shy of technology. Let's be ready to embrace it. Thank you, Elmer. Niël, closing remarks from yourself.
Thanks, Laura. Look, I spoke about how technology makes the business better, how technology is serving efficiency, how it's helping us to manage risk. I think maybe one final comment on where technology designed to serve human needs is really being put to use, and where it's also really, I think, just improving quality of life. So our footprint is such that oftentimes in the past you would find that security personnel would be deployed in remote areas, and they would really be vulnerable, not just security personnel, but also some of your operating personnel. And some of the technologies that have come through, which I find really exciting, are ones in terms of which movements are detected. And these are devices that are buried in the soil and they stay there for 12 years. They detect movement and they send a signal to an autonomous observation device. And these devices identify the movement of people moving towards a particular site. And how that helps is you could then deploy a reaction team and they have they basically see these people approaching and emerging out of the dark, and they can then adopt their behavior accordingly, and that's how you bring proportionality into the security aspect as well. An AI that we use in plants, where a base model for the movement of people is established, and if there are movements outside of that base model, then it's flagged, and that's how you know that you're about to be robbed or that you're about to be attacked. So technology not only serves efficiencies, but it also serves quality of life, and it makes it just a tiny little bit easier and a tiny bit better to also look after those aspects of the business, and I find those particularly reassuring as well. So we're very much committed to technology, and I think this is a journey that it's not going to stop. There's no goal line. Nishen made the point earlier, though, that you've got to be able to differentiate which are, what is rubbish and what is not. But it's worth experimenting and looking at what serves sort of a broader set of interests.
Solid conclusion there, Niël. Very strong takeaway message. Thank you. Nishen, let me hand over to you.
Yeah. Thanks, Laura. Firstly, thank you for this opportunity, and it was a fantastic discussion. And in closing, I'd like to say that we need to be purposeful in our strategic positioning and our technology development strategy, in that we solve for not just our customers, but for the market and the environment in which we exist. A mine doesn't exist in isolation. Its resources, its environment, its people all require due consideration. And adopting technologies that solve for not just bottom line, but solve for the communities, solve for the environment, solve for for the broader purpose is where the true value lies. And I think the intelligent application of various technologies needs to be carefully thought through to reap the full benefit and reward from it. And yeah, I think if you look at blasting, you would think that it breaks rock, but we generate value in what we do and how we apply it, and which is very important for us, that we are purposeful and deliberate in the technologies we employ, deliver and implement.
Thanks, Nishen. So much care given to the activity of blasting rock. I think that's really important. Simon, again, last but not least, closing out message from yourself this afternoon.
Thanks, Laura. And I think just from Engen's side, we are future ready. Our products are future ready. We really focused on emissions and environmental considerations and generating efficiencies for our customers. I mentioned things like AI earlier. There's some very, very exciting technology waiting in the wings that are really, really yielding very impressive and exciting, meaningful results.
Super. Thank you. Thank you, everyone. What an incredible conversation. And if I can add my 3 or 4 takeaways to this discussion, the first is that the starting point is understanding the technologies that really suit your needs on an operation. It's not an off-the-shelf approach when it comes to technology. The second is, as Julie said, people are pivotal in a technology journey, and they're not ever going to be excluded. They're part of it, and how they contribute is what needs to be determined, or how to bring them along on that journey, but they are very much a part of that journey. The third takeaway for me is that partnership is key. We can't work in isolation of each other. We have to work together between technology providers and the companies that will ultimately adopt that technology. It's absolutely crucial. And then the last key takeaway for me is that the technology journey has definitely started. It's not something we talk about in the future or something that we're aiming to do in the next couple of years. We're doing it right now, and we have to take it really seriously, because the benefits are just so significant. We cannot choose to ignore it. And if we want a sustainable industry, then technology is definitely going to contribute towards that in a very big way. Thank you to my incredible panelists. Those key takeaways are my learnings from what you've shared with me today. And a big thank you to Mining Weekly for allowing me to host this webinar. And Shannon, at this point, I'll hand over to you. Big thanks as well to yourself.
Thanks so much, Laura. That does bring us to the end of our webinar. I would like to take this opportunity to say thank you to you, Laura, for enabling such an engaging discussion. And thank you also to our panelists, Dr Elmark Muller from Mintek, Niël Pretorius from DRDGOLD, Julie Courtnage from Mandela Mining Precinct, Nishen Hariparsad from BME, and Simon Prevett from Engen Petroleum. Thank you to our partner, Investing in African Mining Indaba, and our sponsors, Aberdare Cables, BME, DRDGOLD, Engen, Mintek, and TLT Turbo Africa for their support in making this webinar possible. Registration is now open for the 2026 Investing in African Mining Indaba, which takes place from 9 to 12 February in Cape Town. Visit the website for more information. And finally, thank you to the attendees for taking the time to join us for this discussion on mining technologies in South Africa's mining sector. We hope you found this event engaging and informative, and we really appreciate your participation. You'll see that I shared a link in to a video of Mining Weekly's Martin Creamer speaking to Niël Pretorius about DRDGOLD solar plant, if you're interested in that project. And you'll find more interesting videos on our website and our YouTube channel. Our next webinar takes place on the 17th of September at 2 p.m. and will focus on environmental, social and governance, where a panel will discuss the understanding the importance of ESG commitments and the technologies that support them. The link to register for that event was shared in the chat. And finally, the recording of today's webinar will be sent to you in due course. If you have any additional questions, please be in touch. You can reach us at shannon@creamermedia.co.za. Thank you so much for your time, and goodbye.